Hello everyone and welcome back to our course. In the previous lecture, we learned how to analyze risk with Monte Carlo analysis. And in this lecture, we're going to finish up our project by learning how to visualize price distribution. Visualizing the price distribution is going to allow us to make better sense of our Monte Carlo analysis, because currently there is some variability in our predictions, and we're going to make sense of that variability with a histogram. First, I am going to make a new variable called simulations, and I'm going to make a numpy.zeros function. So I'm creating a numpy array of zeros. The size is going to be my number of runs, and this time my number of runs, I'm going to increase it to 1,000 instead of 3 or 100 as we saw previously. Then I'm going to loop for every run in a range of 0 up to my number of runs. I am going to take my simulations, this should be plural, and at the current run, I'm going to assign it to equal Monte Carlo analysis. So this means I'm going to store the results of my Monte Carlo analysis in this array simulations. For Monte Carlo analysis, I do have to pass in the starting price as well as the days, the MU, and the sigma. And then I'm going to store the results of that analysis at the days minus 1. Right, so days we had earlier, we declared this to 365, and we declared all the other arguments as well. So we're good to go. All right. And that's just going to perform Monte Carlo analysis. If I want to visualize it, I have to create a plot. Okay, so I am going to exit the for loop here, and I'm going to call pyplot.hist to create a new histogram from my simulations. The number of bins I can choose, let's choose 100 bins. This is going to plot the distribution of our end prices. Now, if I run this code cell, just let it run for a minute because the number of runs is 1,000. Okay, oh, never mind, there you go. That was quite fast. All right, so we get the results of our loop, and we get this histogram, which shows us the distribution of values. Let's now fill in some additional information onto our plot. So I am going to go into the same code cell, and I'm going to call pyplot.fig text at 0.6, 0.8 for the size. The S is the label. It's going to be starting price, and I'm going to put in here the starting price as 2 decimal places, and I'm going to fill that with my starting price. Then if I rerun this code cell, I'm just going to have an extra figure text. Okay, we just have here starting price, $368.70. That was the starting price for the Netflix stock. Next, let's show the average final price. So I'll call pyplot.fig text again to add text to the figure. I'm going to do it at 0.6, 0.7, so a little bit lower. The string is going to equal mean final price, and I'm going to show it to 2 decimal places. And I'm going to fill in here my simulations. And from the simulations, I can just use the mean function to get the average. Now I'll rerun this code cell, and we will have a second label. We're going to also show mean final price was 369.84. All right. Next, I am going to show the variance of the price. So I'll use pyplot.fig text, and I'm going to plot it just a little bit lower at 0.6, 0.6. The string is going to be variance, and then I'm going to pass in the confidence interval. So I'm going to say 99% confidence, and I'm going to pass in here to 2 decimal places the variable of my starting price, and then I have to subtract my quantile. So the quantile, I am going to declare that as a variable. All right, so let's declare that quantile. The quantile is going to be a numpy.percentile function. This is going to return for us a percentile, and I have to pass in my simulations as well as a number of values. I just want one quantile. So that way I can calculate variance. And also this percentage is going to get in the way, so just remove that and change it to percent, because percentage is a reserved symbol. Okay, then we can hit rerun on the code cell. And this time we're going to have our third label. We have variance here at 99% confidence, and the variance was $368.70, right? And let's see, I'm just going to, next up, let's now display the 1% quantile. So we have this 1 here. So the quantile actually itself is the 1% quantile. So let's display that. We're going to add pyplot.fig text, and we can have it at 0.6, 0.5. And I am going to pass in my string here. The string is going to be my 1% quantile, and then let's put in as a string, we're going to put to 2 decimal places our quantile. Then I'll rerun that code cell and we'll get our results. We're now going to have an extra text. Okay, 1% quantile is $0. All right, now let's plot a line at the 1% quantile result. So I am going to, for that, call pyplot.axvline to create a line. The x is going to be our quantile. So it's just going to be a slope of 0. It's going to be just one line. All right, so x is quantile. Then we're also going to pass in a line width. Let's do 3. Then I'll rerun this code cell. And we're going to get our final price distribution for our Netflix stock after a number of days. And we also get our quantile. Okay, so the quantile was 0, and the value at risk for each Google stock was what we had earlier, and this means that the amount of money we'd lose at most 99% of the time is $0. So this quantile here represents the value at risk 99% of the time, which is 0. So that means that there's high confidence in this Netflix stock. And that is how we can visualize our price distribution for our stock. You can actually do this with any of the stocks that we have. All you have to do is use that stock's adjusted closing price as your starting price and change the sigma to get returns at your stock. That way you'll be able to see the price distribution for all of your stocks. I'm just going to move this a little bit over to the left. Let's change this to 0.3. That way it's not going to interfere with our histogram. Because if you set it, the X value in fig text to 0.3 or maybe even 0.2, that's going to make it easier to read. You can also increase the number of runs that you're doing. Currently we're using 1,000 runs for our Monte Carlo analysis here. And this means that we're going to be having 100 different simulations, or 1,000, sorry, we have 1,000. But you can increase that to 10,000 or higher to get a bigger simulation. Congratulations everyone on completing another course. I'm excited to see what you do from here, so feel free to share your success with us and your projects. And I will see you in another course.